Okay, I think we may begin. Thank you everyone for joining the Data Science Applied Research and Education seminar. Before we begin, let me announce the statement of acknowledgement from our traditional land. We wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been a traditional land of Huron-Wendat, the Seneca, and the Mississauga, South Cribben. Today, the community is still the home to many indigenous people from across Coral Island, and we're grateful to have the opportunity to work on this land. Let me introduce myself briefly. My name is Ivor Park, and I'm the professor of statistics and psychology at the University of Toronto. The ARAPS seminar aims to bring data scientists who span multiple disciplines and work on important and interesting issues, both applied and educational. And it's always to increase discussion and collaboration between data science researchers across a variety of disciplines. ARAPS is a partnership between the Department of Statistical Sciences at the University of Toronto and Kent, Ontario, and its partner universities, which include Brock University, Harvard University, Wilfrid Laurier University, Mass University, Queen's University, University of York, University of Ottawa, University of Toronto, University of Waterloo, University of Windsor, and West University, and York University. And let me introduce our speaker. Dr. Cribben is a professor at Ivor Classical Business, and his research focuses on time series analysis, vector models, and high-dimensional analysis with application in your imaging. Dr. Cribben completed his PhD in statistics at Columbia University in 2012 under the supervision of Dr. Martin Lingus. Please welcome Dr. Cribben with applause.
Thank you, June. Thank you for the invitation as well. So the first thing you'll notice is in my research interest, he did not say reproducibility. So I published a paper. I hope none of you have looked at it because I want to engage with you as much as possible. So if you're on your laptop, don't look it up. Okay. Hopefully, I want you to think during the seminar, and I want you to engage with me as much as possible. Okay. How many people have attended? I know Rohan has organized a couple of conferences on reproducibility. How many people have attended these in the past? Oh, bad for Rohan, good for me. Okay, you should attend these things. These are really important. So today I'm going to talk about the state of play reproducibility in statistics. I'm going to assume that you know very little. So if you have attended this conference, that's okay. And I'm going to present work that got published last year. I presented this last year, and June said, would you like to come to Toronto and present it to at the ARU seminar, which I'm happy to be here. So it's not only that paper. I have some other results as well that I'd like to share with you. And if time permitting, how much you interact with me, I'll also discuss something about education, statistical education as well. So we'll see where we go and how long it takes me. First of all, do I need a microphone? Alina, do I need a microphone or is it okay? It's okay, I thought so. So while you're listening to me, I've listed these questions. So I'd really like you to think about these questions as you're listening to me, and also as you're doing your own research. So how important is reproducibility to statistics and data science? Who should be responsible for reproducibility in statistics and data science? Should it be researcher? Should it be the journal? Who should that responsibility fall on? How could reproducibility be improved? Well, first of all, you need to know that there's a problem with reproducibility before you know that it needs to be improved. And then what is the best strategy to guarantee reproducibility in statistics in data science? Okay, so I would like as much feedback on these questions as much as possible. And while I'm presenting the material, think about these. I'll play them again, or I'll put these on the screen towards the end of the presentation as well. So as most of you here are students, so as you're thinking about your own coding, your own data, doing these things with a reproducible mindset is important, but at the same time, it's time consuming. Okay? So with that, I'm just going to give some background if you don't know what the definition of reproducibility and replicability are. I'm just going to give you some background on these topics. So these are often cited as the cornerstones of reliable science, and studies that we can't replicate or reproduce, we should automatically treat these with caution. So you might have seen over the past decade in top journals such as Nature, Science, and in The Economist, we're going through what they call a replicability crisis, okay, or a reproducible crisis. And if you've read, I don't know if you've read this John Ioannidis article in 2006 that most published work is actually false. I don't know, we're probably too young to have read this before. But multiple studies have demonstrated that scientific results are often not reproducible across research areas. The sort of focus originally was on psychology and medicine, and now it's reaching to other quantitative fields, and now statistics have been thinking about this, but we haven't looked at it. We've only looked at this really recently. So why would we do this? Okay, so there are the importance and benefits of reproducible and replicable research. Well, what are they? So for you as researchers, as authors, why would you do this? Well, the idea is, well, it could increase the impact of your research. Okay, so if you write code that someone else could use, if you publish your data that is freely available, somebody could take your methods and probably compare it to their method that they're developing. Okay, so which might lead to more citations and more impact. It could also elevate work efficiency. So most of you are not in charge of groups, but you might have taken up code or data from another student recently and started working on that to try and improve it or to try and build on that. If this is not done in a reproducible or with a reproducible mindset or done in a good way, reading somebody else's code, analyzing their data is very difficult. Okay? So creating efficiency within your groups so that one student can take the code and the data and build on it straight away. If you do this with a reproducible mindset, this will create efficiency. Also downstream as well, if you do this, possible meta-analysis might be possible. Okay? So that's for the authors. For the readers, so as you read papers, you would assume that if somebody publishes their code and data and make it freely available, you trust it. Okay, so the results that are published in that paper, you would begin to trust it more. You would have a higher perceived quality of research. And then this goes back to the baseline methods, that if they are freely available, that you can just take them and build upon them straight away. Okay? So these are the benefits for you as the reader. For the public, as most research is funded by tax dollars, it would reduce or prevent fraud or scandal. So I don't know if you're aware, but the number of retractions in journals is increasing quite dramatically in recent years. Okay, so what does that mean? Well, that means that people are doing bad things in their research. Okay, so if you make these things freely available, we would reduce or prevent fraud or scandals in research, and then it would also increase the public access to this research, which is a public good because it's mainly funded by tax dollars. So in 2016, Nature did a survey, and they asked the question, I think they surveyed approximately 2,000 people, is there a reproducibility crisis? 52% said yes, a significant crisis, and 38% yes, a slight crisis. Okay, so 90% of people say that there is a crisis with reproducibility. So what is reproducibility? What is replicability? So reproducibility, which is going to be the focus of this talk, is the ability to take somebody's data, take somebody's code, run it, and obtain the same results that they found in their paper. Figures, tables, all of the results. Replicability is something slightly different. So it's the ability for you to collect, say, new data on new subjects. So you go out and collect a new sample and find similar results. Okay. So as statisticians, we tend to do this more. In data science, we tend to do the first one more, where we take somebody's code and data and try and find the same results that they found in their paper. And that's going to be the focus of what I'm going to talk about. So both of these ideas facilitate this ongoing self-correcting nature of science. So we believe that a new scientific discovery requires both confirmation, so we repeat it many times, but also, we want to see how robust it is. So if we change things slightly, do we get a similar result or not? Okay, so this is the way science works. And so we want to study, and this is why we think about our statistical methods. What are the limitations, okay, of this scientific system? What are the limitations in your methodology? You should, sometimes in papers we have this at the end of it, discussing the limitations of our methodology. So replicability is generally regarded as the gold standard, but is often difficult to perform. Typically statisticians don't always go out and collect data on subjects. So hence, reproducibility, or some people call it computational reproducibility or computational analysis, is this compromise. So with the ever-growing focus on quantitative sciences or modern computation, this is the compromise between replicability and reproducibility. So as our computational algorithms increases, it is assumed that the computational component of work can easily be reproduced by not only the original authors, by the other researchers too. So how many times have you yourself done some research, written some code on some data, you forget about it for a while, and then 6 months later you come back to it and you have no idea what you've done, okay? So if you can't reproduce it, how do you expect somebody else to reproduce it? So if you could start off all of your analysis, your methodology with this reproducible mindset, it will save you some time, hopefully other people in your group some time, and maybe 6 months down the road, you some time again. Okay, so the reality, as you expected, is very, very different. Okay, so there's a multitude of problems in reproducible research. The lack of detailed instruction for the analysis, code that is all over the place. Highly customized workflows, increasing complexity of computational algorithms, something that can't run on your own laptop, or large data sets that require specialized computer resources. So these are some of the issues that people run into. On the most frequently occurring issues are access to the real data. So we're going to look at this later on. Availability of the final version of executable computation code, which I've talked about before, full details of the analysis workflow, and complete description of the computer environment. This might seem like a minor point, but it's actually critical, okay? And so Donahoe in 2010 said, well, we think as quantitative or computational people that we don't really have any issues. We can reproduce our own code. We're very open. We share code and data with one another. But he said that we're also going through a credibility crisis as well. And that was back in 2010. So in my experience, statisticians are pretty good. We're open to sharing code, data with one another. I email statistician. Most people are open to sharing their code and data as a possible baseline for my method. But the problem with that is there's no quality control. I mean, it could be, I might be able to use it, I might not be able to use it. The data might not be in full, the code might be missing functions, and so it would involve an interaction that the other statistician would need to do, spend some time on, and there's no real benefit to that. So there's been work on reproducibility in other computational fields. So econometric research in 2009, OR in 2011, and then you can see the rest of them are much more recent. So chemical engineering, economics, transportation, evolutionary computation physics, computation biology. So you can see that these are much more recent. However, to the best of our knowledge, there has been no study done on reproducibility in statistics, right? So that was our motivation for this work. However, there is a lot of related work that has been done on reproducibility or computational reproducibility. So Stodden et al. Looked at reproducibility on various computational research, and they have a science paper and a PNS paper on this. There's other methods, there's editorials, as you'll see. So this is an editorial in 2009 in Biostatistics talking about computational reproducibility and what the Biostatistics journal should be doing. And then you can see that there's a lot of more recent related research on tools that could help with the reproducibility. Okay, so these are some of the tools. I'll refer you to the paper for more of the tools that help you with your computational reproducibility for your research. So our software, Journal of Statistical Software papers. So with that in mind, what we tried to do was we tried to look at the state of play of reproducibility in statistics. And so we looked at 93 papers studying fMRI data. So we focused on fMRI data in 7 prominent statistics journals from 2010 to 2021. Why did we pick 2010? Well, in 2009, there was that editorial in Biostatistics, so we felt as though that was a good point to start. And the journals that we looked at were the following 7 journals, which I hope you can agree with are prominent journals in our field. And journals that publish methodology and applied work on functional magnetic resonance imaging. So that was the study that we looked at. Why did we pick fMRI? Well, we felt as though we had expertise on this data. We felt as though we understood this data, so that if there was complications in some of these papers published here, that we could do a good job in trying to fix those problems. Okay, so that's why we chose fMRI. But we will discuss other application areas later. Now, the interesting part of this is, yes?
Sorry, all of the papers selected? Like,
All of the papers. We selected every paper from
that's
these.
everything.
That's everything there. It's a very good point. Yes, everything there. So as you can see now, we have each of the journals here. And then an interesting part of this is we looked at the requirements for data and the requirement for codes for each of these journals. Now, this was not in 2010 when we started the study. This was in 2021, 2022 when we were carrying out the study. Okay? So if you start reading these, you'll see words like encourage, strongly encourage, expected, requires, all of these types of words. Okay? So AOAS for data, strongly encourages, code encouraged, biometrics encourages, biometrics for code strongly encourages. So you can see even between the same journal on the requirements for the code and data that there's not agreement. That both of them don't say strongly encouraged, encourages. There's differences between. Okay. So Biostatistics, there is an opportunity to present extensive analysis. And this was the same Biostatistics journal in 2009 said, we need to do this. And here we are in 2021, 2022. JCDS, strong, expected, right? They're expected to submit coded data sets as online supplements. These will be important when we start looking at the statistics, right? JAWS is the interesting one. So before September 1st, 2021, ASA strongly encourages authors to submit data sets, coded or programs, and or extended dependencies that are directly relevant to their submitted articles to query methods. Since September 1st, 2016, authors publishing in the ACS section of JAWS will be asked to provide materials that demonstrate reproducibility. So from 2016 in ACS. After September 1st, 2021, they're going to, they must include code data and the workflow to reproduce the work presented. Okay, so very strong advice from JAWS. Their SSC should, where possibly, be accompanied by the data and computer code, and then statistics to medicine expects and requires. Okay? So I just want to give you a sense of The words that are being used in these journals in 2021. So, how many of the 93 papers could we reproduce?
3.
3? 7? 18? What? 50%. See, I've set the bar already, you know, I've biased you completely. I should have opened with this. So 50%
Clarification.
clarification.
Is this with communication with the authors or absent?
That's a very good point. So absent, so from the journals only, no communication with the authors.
Okay.
Because we believe that there's no quality control in that way. Like, you know, of course they could help us out.
Yeah.
That's a lot of work on their behalf too. So no communication. That's a very good point.
Exactly, or after turning out.
So we did everything we could. We were on the sides of the author. So we were very lenient. If they were approximately close, figures were close, we were very lenient. If they reached our minimum bar, we said yes. So we did everything we could. But that very rarely arrived. It was very much a 0 or 1 in most cases. And I'll show you why in these slides. Okay. So June knows the answer if he remembers. So the answer was 14. So whoever said 15, well done to you. So 14 out of the 93. Okay. So and this goes to this gentleman's question in the wine shirt is, well, what's happening? So what's happening here? So this is a table of all journals combined. We also have in the paper journal specific statistics. So if you're interested in them, I'll refer you to the paper, but I'm not going to go through. So the interesting part is, you know, if you look at code provided, so code provided 47, code not provided 46. Already half the papers disappeared. Similar for data, so data provided, data not provided, 5142. So again, half are not submitting code, half are not submitting data. And we're focusing on, I mean, you know, we can discuss this. This is on the real fMRI data, the real results. Okay? So we break it down.
Is there code and data?
So code and data is here. So real data, 14 out of the 93. Now, what is this parenthesis? This parenthesis indicates that an R package was provided and they provided the script to reproduce the results. We commend people, we like our app. But if you're not going to give a script for the paper, then it's very difficult. And I'll explain for fMRI why that is in a few slides. So we commend our packages take time to produce. You have to interact with CRAN. Not many people have gone through this, but many of my students have. So we like our packages, but provide a script here. If you've gone through the trouble of doing an R package, the script should be pretty easy as well. So 12 provides simulated data. So you could take this as, okay, it provides simulated data, that's good, but we were mainly focusing on the real data. So that's why it's 14 out of the 93 rather than the 26 out of the 93. Code failed, so that means errors in code. Again, we did everything we could to help out without communicating with the author. And then code not executable means that there's missing our scripts, functions missing, big things missing. Just can't do anything with that. And raw data we have here, the raw data that was 12 pages for raw data. Right? So I assume that most of you are unfamiliar with fMRI data. Okay, so functional magnetic resonance imaging, and that's why we will discuss these results in a few slides. So fMRI data usually comes raw, and then you go through a sequence of pre-processing steps. And then you get data then that you fit your model to or your methodology to. Those pre-processing steps, they are not standardized in the field. Okay? So there's not a standard procedure for carrying out these pre-processing steps, like the first one, second one, third one, etc. So if you pre-process it in a different way, you'll get different data and different results. Okay? So that's why providing raw data is good, but unless you provide exactly the code on how you pre-process the data, it's almost impossible to get the actual data. So if you're going to provide the raw data, you should also provide very, very detailed description of your pre-processing step, the code, the log, the workflow, everything. Otherwise, it won't be. Okay, as I said, we've got in the paper, we've got journal-specific statistics. But again, my goal here is not, to look at all the journals in isolation. But if you're interested in them, I'll refer you to the journals. And looking at the matches between what they state and then the statistics for the journals is interesting. So this is just a summary of what I said. So out of the 47 papers with computer code available, we find 26 with code that runs smoothly, 5 with code that failed, 16 that code was not executable. So our functions were provided, but there's missing data or missing key files. 10 papers provide our software, 3 of which of which 3 contain user-friendly reference manuals. So as I said before, we like the idea of our packages, but please provide a script for the code used in the paper in order to obtain the results in the paper. From the data perspective, we find 42 published papers provide no real simulated or raw data. Out of the 51 published papers with data available, we find 23 provide the real fMRI data, 16 with simulated, and 12 provide the raw. Okay. And then hopefully you can see this. So here we looked at trajectories. So I wanted to come out and, can we be optimistic in any way? 14 out of 93 is not great news to take home. So here all you need to see is trend. You don't need to see details here. But what we're looking for, so this is the number of papers on fMRI published in each journal during the period. So this gives you an idea of how many papers were published in fMRI over time. So biometrics seems to be increasing, and then the rest are, they fluctuate a bit. Data provided, this figure here shows us this provides pre-processed data. So again, being an optimist, and this is over time, being an optimist, we'd say, well, we're trending upwards. The idea that people are providing in the past few years, the number of people providing pre-processed fMRI data is going up. This is good. Code provided, again, this red here is, you can see that it's trending upwards again, so we're going to take a message comments. This is also trending upwards too. And then code and data work, again, a little bit of fluctuation, but hopefully you can say that this is also trending upwards as well, right? So if we were to take, and we haven't done this yet, but if we were to take papers on fMRI 2022 and 2023, hopefully this pattern will continue, this trending upwards pattern will continue. Okay, so we have some recommendations, okay? So in terms of, we break down the recommendations is, okay, what should we do? What should you do? You are the next generation. What could you do to make these statistics better? So I'm going to talk about some author recommendations, and I'm going to talk about some journal recommendations too. And you can agree and disagree, and hopefully we can have a conversation.
Sorry.
Yeah.
For you.
Yeah.
So these 14 out of 93 are the ones that were more you were able to reproduce, not replicate.
Yeah.
Reproduce. Were those 14, did they have better impact than the rest? That was one of the things you were sort of.
That's a good question. We did not look at that in terms of impact. Yes, because we tried to, because I've got papers in this set. So we tried to move away from looking at authors. You know, I mean, we don't want to
Yeah.
we don't want to label groups or people, and you know, I don't want to tell you where my research came out and all the things.
Right.
We tried to. I mean, I think we should do it, but at that time, we tried to stay away from labeling certain authors. We didn't want that to happen. We didn't want people to feel bad that we couldn't reproduce their work.
I'm just wondering whether the statement that having reproducible
Correct.
work actually does lead to that.
Yeah, that's something that we should definitely look at. Yeah, in the next step.
Because
Yeah,
it obviously takes a lot more effort
correct.
that you're taking time away from doing something else.
Correct.
To do this.
Yeah,
So,
yeah. And if their coding data is available, have people compare their method, have they become the baseline method? in
Right.
these cases? I think that's a great point. Yeah, yeah.
Wait, what about like your papers?
I said I didn't want to label people. What about my papers?
Yes, was it included?
Oh yeah, it was included.
And what is it?
So it was included before I did this research stuff.
Okay.
Yeah.
Yeah.
Or we can discuss that at dinner. It's mixed, shall we say. But I didn't go back. You're wrong.
How much, did you do any changes to the code, or does run means like you click run and it runs, or like do you change language, like how much?
We did as much, we gave as much flexibility as possible. So we spent time. So as the statistics show, there wasn't that many papers where we actually had to run code. So a lot of the plans erred very quickly, either because of the code or the data. Any paper that required work, we spent time and to help it become.
Really tried to help me.
We did everything we could, and a lot of the time it was nothing possible because our whole function missing, and we had to code that function ourselves. So we did, again, we were on the author's side, and we tried to do everything we could. But in a lot of cases, there wasn't much to do.
What is it that why would somebody submit code that they then just don't download themselves and see that it doesn't run? That's like there's no consequence.
What's the incentive? What's the, I mean,
No, but then why do it at all?
because journals will say, okay, you know, like Jazz said, you have to upload.
And they themselves don't just check, does it run?
So one of the journal recommendation factors, so Jazz has an associate editor for reproducibility
Right.
since 2016.
So they have to check whether code was uploaded, data was uploaded.
No, they should check that it runs.
So whether they did or hasn't happened.
Are there any type? Yes, I will refer you to Jazz's results.
Very interesting.
They are the most interesting case because they are the ones that are at the forefront of this since 2016. And because they assign an associated for reproducibility, you either assign a reviewer to go through the code and the data and find if you can reproduce. And that's at once you get through, I think, the first round of revision. Yes.
Yeah. Part of the paper yeah, possible modify their code. That's awesome.
Yes.
I wonder if this author.
That's it. So that is a very good point. That's something that we talked about. So multiple people did it. You know, so it wasn't just, you know, the two authors of the paper, I think other people paid people to go through it as well. But I thought that given our knowledge about more like data, that this would be we would be good at it, especially in terms of the data side. But you know what? Who's policing the police? That's what you're asking. If we're the police, who's policing us? Well, then who's policing the police? You know, so you go, you keep on going. Anyway, yeah, anyway. Yeah, that's our second question.
But me, really, not only the running the book, but including the reading also different package version, they should be all included so that like one part.
Right.
Instead of like the integration like they make the code.
I agree.
So but that means we split now not only.
No, there was some very good papers. If you read our paper, we highlight We don't highlight ones that didn't do well, we highlight some examples of very good papers with very good flows, workflows and, you know, versions of software and everything. So there are good papers to mimic that. But
I don't know if this is addressed, but these are comfortable with the data, aren't they not? In part, is this presented by whatever?
so
You can't up the shared data?
So I will bear with me, right? Just, you know, bear with me for the moment, okay? And if I haven't answered that in the next X number of minutes, ask it again, but bear with me. I have a message coming that sort of is related to that. But you're right, this is fMRI data. fMRI data is somewhere in between truly proprietary and there are open data sets now. So if you go to Open Euro, Open fMRI, there's some data sets that you can download and you can start. But of course, there's going to be data sets that, you know, you have to be more careful. We have not adjusted for that yet. Well, we could adjust for that, yeah.
Because I think it's like a clinical file.
Correct.
Yeah.
So just bear with me on that second part, okay? Yeah. Okay, so of course, yes, yeah, will do. I'll repeat the questions when they come up. Okay, so the author recommendations. So we think that although the statistics for JASA weren't great, the application and case study section of JASA, you know, we follow their recommendations. We think that this is a good idea, and there's an example that we provide that, you know, of a really superb workflow of their methods. So they provide detailed computer materials, including step-by-step workflows to demonstrate reproducibility. For fMRI data, we said include all dependent data and files. So again, this is specific to fMRI data. So basically all the pre-processing steps, templates, brain masks, parameter settings. This is for fMRI data in particular, without the need to contact the authors. Obviously, if things are small, contacting the authors is not a bad idea. But how much, I mean, I engage with neuroscientists on my methodology, but how much do you want to do this with your research methods? So share computer code in an appropriate public repository by using persistent links. So this is quite common that, you know, we'll put it on our professional website, somebody will do an institution and those links stop working. So use either a personal website, GitHub, somewhere where, you know, it's not going to change over time if something happens. Provide manuals. So for our packages, provide manuals and clear paper scripts. So I've touched on this before. If you're going to go to do the work of an R package to create an R package, create a script for your paper as well. Okay, so these are further author recommendations. If you're going to provide the raw data set, provide the pre-processing steps rather than a link to just the raw data. So in many cases, papers for their data would say, well, here's the link to the public data set, as I said, on Open Euro or something like this. But without the pre-processing steps, there's no way I can reproduce your data. It's just almost impossible. As I've discussed before, there are no standard pre-processing pipeline, like this step goes before this step. Everybody uses slightly different software. So this is, if you've just provided the raw data set, it's almost impossible to recreate. So we think that you should mimic this Athena strategy in the ADHD 200 sample project. So they provide pre-processed data sets, pre-processing script, log file that clarify the manipulating process for each subject. Okay, so this is the level of detail that you will need if you're supplied with the raw data. In terms of journal recommendations, we believe, and you can disagree with me, we believe that they can be the gatekeeper. If the journals tell us to do all of these things, we will do it. Okay, so if they say that everything there's going to be an associator for reproducibility, we will do our best to make it reproducible. Now, at what level will that survive for 10 years? Who knows? But so in terms of journal recommendations, we we think that they should clarify the access to materials. They could do this by assigning a DOI, so digital object identifier, to the computer code and data. So this would mean that you could cite somebody's code and data. So you're getting some efficiencies, you're getting some credit for doing this. So JRSSE is actually quite good at this, so that if you go to JRSSE past published works, they have a large amount of computer code and the related data sets in chronological order. So they do a pretty good job, even going back quite a far way. In terms of, as a field, what we should do, we should maybe think about having a data or material availability statement. And personally, I would like this to be not in the back of the paper where we put, discussion about supplementary files. Why not put it right beside the abstracts, saying, this is what's available. The code is available, the data is available, it's on GitHub for reproducibility. And have this standard across all journals. In some way come to agreement on where to put this, rather than in the back of the journals or appendices or supplementary files. Biostatistics created something called a kite mark. So they kite marked certain papers. They said, they gave a paper D if the data on which the paper was based is freely available. C if the author's code is freely available. And then R if both code and data are available. So that's, in theory, that's really good. So straight from the start, you'll know what's available. However, from our experience, on the 13 papers that were published in biostatistics, we found 3 that were C marked, 1 that is D marked, and 2 that are R marked. And even the ones that are DR marked for the data, they only provided simulated data. But this sort of idea of identifying papers either from a material availability statement or some sort of kite marks is a good strategy. Further journal recommendations would be to replace these, what I would call softer words. So encourage, expect, and should with require and must. Much more forceful statements. As we've discussed, I think this is becoming more and more common. Assign an associate editor for reproducibility, similar to what Jazz have done. Now, this point here is a little bit more controversial. This would require a lot of work, but I don't know about here, but in my PhD, I had to do 2 semesters of consulting before I could graduate. So here I'm getting nods going, no, we don't do that. So a possibility is create non-profit reanalysis centers attached to high-level or top statistics and biostatistics departments, similar to these consultancy groups that we have. So that is run by PhD students in these departments. So have some sort of setup in the top stats and biostats departments across the world, and they're in charge or they're affiliated with some journals in order to do this reproducibility check. Again, this is very wishful thinking, but it's a possibility. And then reward for authors and referees. So I'm in a business school, and here in a business school, they are great at handing out awards, okay? And in statistics, we don't hand out as many awards. So every conference has an award, multiple awards, best paper. I mean, we've got best papers, but they also have best referee award. So this is something, if you went above and beyond your referee, or if you did a lot of reproducibility checks, perhaps we could have an annual award for each journal. And also the same for authors. Maybe if you go above and beyond in terms of reproducibility for your data and your code, that could be an annual award from each of these journals with some monetary value, preferably some certificate or a free attendance to some conference, in order to incentivize people. This is not going to change until we incentivize people to do this. Okay. So just some conclusions. So we conclude that while several journals have good policies in terms of reproducibility, those statistics of 14 out of 93 are pretty poor. I was surprised by that. And in our opinion, the level needs to improve. So limitations. So as we've discussed in terms of the data being proprietary. So will this generalize to other application areas? So what are your feelings on whether this will generalize to an application area? Is this unique to fMRI? I'll refrain from saying maybe my next statement. So what do you think? Not Rohan, obviously. They seem low. Is it because it's fMRI data? It's out there, okay. Agree? Let me get you to commit. Always commit. Agree, it's low because of it's in healthcare.
Okay.
Agree? Disagree?
Believable. That's it.
Believable. Okay. 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 So as this gentleman said, we did not contact the authors, and then as I discussed before, so fMRI data, it's not very open. There are open data sets, and more people are uploading their data sets to these. There's this move or drive to upload data sets, and that people can use them and download them. The problem is though they're in raw format most. It's you have to pre-process them. But we think that things like stock prices and returns are more open. We can download more freely, and data that is truly proprietary. So real healthcare data, where we have to be careful with how we put that online. So another thing that we could do is establish a scientific culture that appreciates and rewards. The way we do that is we need to incentivize people to do this. If people are not being incentivized in some way to do this, without the awards, if they're not being cited more, how can we incentivize people to do this? So why would we do this? And this relates back to the benefits and importance. So it could be used as sort of baseline method that all other methods compare itself to. So that's one thing that I need to check.
Is there a reproducibility award?
No. No, there should be. I mean, if on the reviewer side, the journal side, any side, there could be something like that. That would incentivize people.
If we increase our scope to like general neuroimaging, there is an award given by OHPF for reproducibility, and it is held in annual conference.
And it's what, sorry?
It's an award for those who really did their work in a reproducible way. I think the award is like $1,000.
So not in statistics, that's in neuroimaging.
In general.
Yeah, human brain mapping. Yeah. So I think that journals should take this responsibility, and if they tell us to do this, or if this is a prerequisite, we will do it, okay? And then in terms of, and this is I guess important for the next generation, it would be beneficial if even when we're teaching coding, so and maybe with ChatGPT, this is when they give very nice commented code with lots of comments beneath it. Maybe this is generative AI will help us with this. But if we can teach with a reproducible mindset, not only is this beneficial to academia, but in industry as well, to write code with a reproducible mindset is important, because usually you're moved on to another team or another department, somebody's taking over your work. And so this is not only important for us as academics, but also if you're moving on to the private industry as well. Okay, so how much time left? Oh God, okay. So I'm not going to get all through my slides. That's good. Okay, so the paper is here, so it's on archive as well. If you're interested in details. As I said, here's some of the questions to be thinking about. I'm not going to spend much time on this. So obviously, if you can imagine, this took us a fair amount of time. This was prior to ChatGPT arriving on the scene. So of course, once it did arrive on the scene, we were worried that all of this could have been done by it and not by us in seconds, microseconds. So of course, what I did was I said to ChatGPT, what are the reproducibility rate of papers studying MRI data published in the following journals from 2010 to 2021? I paused before I hit enter. So who thinks that ChatGPT could have done all this work for us?
It provides specific description.
That's it. That's what I gave it. Okay.
By chance, maybe. Close.
Do you think it'll give us a statistic?
Oh, what is this? Right,
A number?
what reproducible, I presume the question, what is a reproducible rate, should be understood as, give me a number.
Give me a number.
Represents rate.
Yeah.
Or something.
Yeah.
I can give a linear number, right?
Okay.
Yeah.
Okay.
And it'll also give you a whole bunch of carbon,
Okay.
blah, blah, blah.
Blah, 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 blah. Okay. So this is what I get. So took a deep breath, we were happy, and was not all involved. So it is interesting. So some of the references that it cites down here, so yeah, blah, 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 blah. You know, scientific research, this is hard to do, they don't have real-time data, those things are change. But the references that they gave us were references that we cited in our paper. So it's not all garbage, right?
It doesn't even provide.
No, it's not right.
Oh,
No,
but
it's
this is historical data,
correct.
so this is not something they need to look up.
No, that was my point, is they can see this. This is not something, we did not look at the current time.
Right.
They have this data. Yeah. So their excuse is not right.
Yeah.
Okay, I'm under time. I thought I wouldn't be under time pressure. Okay. So going back to this latest one. Okay, so this is the update. Remember, at the end of my presentation said an update. So that's previous one. The recent work is we attempt to reproduce a much bigger sample size, 241, which I'm in the business school, so I understand this data too. Economics or finance data published in 8 prominent statistics journals. More recent, so at the end, so 2021 is when the last one started in 2023. There's some overlap between the journals because obviously Journal of Business and Economics Statistics won't publish that all. So percentages.
Why is that not there? I mean, it's so distinct.
I know statistics publish economics. They have papers with economics or financial data. They do. Yeah, I mean, we looked it up. I can't remember off the top of my head how many, but they definitely have some. Yeah.
Is there a reference page for the paper format, like from the 241?
I don't have it off the top of my head, but I can find it. But it's not non-significant.
It's got no significant order rate.
Yeah, I mean, obviously there's ones that dominate here, you know, but we'll have journal specific percentage.
So what is the data like? It's just say economics or finance data, but I'm thinking it could be something that's really public, but it could also be something really proprietary. So
Yeah.
the idea of like,
It's mixed. So anything that related to finance or economics, so I'm sure.
Why is the journal finance review?
So statistics,
Okay.
I'm not in finance. Yeah, so it's, I mean, if you think our reproducibility, right? So these are journals that I understand, you know, so that's why, you know, we're in the field of statistics, we're looking at reproducibility. Well, the most important thing relates to this latest question of, is it to do with application area? Is it fMRI specific? Or most people would think that this data is more open, more freely available, not in all cases, not in the Journal of Finance, but in statistics journals.
Well, there's lots of economic and finance data that's proprietary.
Correct.
Trade execution.
But do statisticians have access to that?
Yeah.
It's hard, yeah. So that's why we just wanted to see, is fMRI data, people think straight away that it's proprietary sub markets. Yeah. We're here, you know, is it similar, is it very different? We get 100%, we get 95%. So what do people think? Quickly, any answers quickly? 100? 85? 8%? 20? Okay,
Somewhere in that range.
so here's what we find. We changed it slightly, so we separated a little bit to work partially for. I'll refer you to the paper exactly what that means. 17, work completely. Not too close to 7.0.
Yeah.
Then when we combine these together, we actually get pretty much 15%. So bigger samples are yes, but in terms of application area, very simple. Are we surprised by this? Great. Okay. So this, this was really interesting to us, and this is, currently being written up, so I don't think it yet, but I will want to. So with that, these are just, some comments.
Sorry, what was the dates again?
2021 to 2023. So at the end, so at the end of, so the first one was 2010 to 2021, and then and then I will end with 2 more slides. So I was also involved in reproducibility in the journal Management Science. So Management Science is a big sort of across all of business schools, pretty prominent journal. And they did a reproducibility study themselves. So they took this sort of crowd science approach where they emailed all reviewers, that have ever reviewed them. And they got more than 700 reviewers who reviewed 500 articles before and after the introduction of the data and disclosure policy. Right? And then they looked at reproducibility rate. So conditional on the data and code being available, they got a 95% reproducibility rate. Conditional on being available. Not conditional on that is 68%. And then for 29% of our well, at least part of the data was not accessible. So rates significantly higher than statistics. So this was a real big effort by Management Science to do this. They also did a replicability study as well, where they got the top 10 most cited papers to see if they could replicate those results. And then I'm happy to chat about any of this. I will leave it here. I want to discuss, given that it's also an education all for our seminar, we wrote this paper on ChatGPT and the influence on education, and we have some interesting points, especially in terms of grading. We use in terms of grading and how it can be used in terms of coding. What does coding look like for our future? And then the last thing is teamwork. I don't know, in statistics and in our classes, people in groups. What does that mean now? In my experience, teams now need to be smaller because they can work with it. They don't need bigger teams. A lot of the time they don't spend talking about with ChatGPT and codes. So I will leave it here in a few minutes that you might have some questions. But thank you for your time. Sure.
When I asked about your reanalysis, how would their work be funded? Would it be part of the review process?
Oh, that's a really good question. So the question was in the reanalysis center. So I said that one of the let's just go back. Okay, so the question here about the reanalysis center. So there was a question on the Zoom about who would fund this. So if I would think about it in 2 ways. The first way would be no one would fund it. It would be a part of your education. So just like I had to do 2 semesters of consultancy, PhD students would do 2 semesters of this. Now, I'm not saying that everyone's going to do this, but this could be a part of your program. Another way to think about it is we would get journals, funding agencies, NSERC to fund these reanalysis centers as well. So that, and then they could pay the PhD students more money. I think from our discussion with Emmett, more money to the students to do this work And so everybody's winning. Science is winning, underfunded students are winning, and so we get the funding agencies, the governments to do this. But there are just some things that I'm thinking off the top of my head.
Any other questions?
I just have some comments because I have figured out another problem that is related to reproducibility, but it's not exactly something because in your definition of reproducibility is about the code in the data screens, data just a bit, but another is just like about the technical flow. Say people flows appear and you see like 30, 50 pages on the flow.
Yeah.
And the thing is like the reviewer is never go
Correct.
for the detail of the
Yeah.
so there's so many faults there. I think
It's this exact same problem.
the problem is like the now the books is publicly available.
Yeah.
Nobody, only the people that working on the area is gonna take that.
Right.
Look at it, and then by law, I cannot apply the technical book here. So I think this might also be like ask some PhD students and get their pay, get check.
Yeah, I completely, and that has come up before. It's the exact same. People aren't going through these proofs, even the reviewers in great detail. And what does that mean? Yeah,
Have you had any conversations with people in like sciences where they can't review reproducibility and they need to replicate a study and get their opinion on the fact and statistics, but to make something reproducible is really not that difficult? Like, do they think you're a bunch of degenerates that we can't like even meet such a small bar? Because like if you went to a social scientist who do these huge field studies,
yeah,
it'd be like millions of dollars to replicate it. Like they would say, of course, take an extra day to make sure that you produce your own work statisticians. What do people in other fields think of it?
So I've only presented this, I think, 3 times, and it's always been to statisticians. And so I honestly I don't know what they think, but I mean this isn't it's all the quantitative fields. If you go to computer science, you know, I chat to computer science and they have the same issue. It's not just so that their rates are just as good or as bad as ours, whichever way you want. But in terms of scientists or outside field, I haven't had that discussion with them. But maybe they think that, but I'm not sure. But would they, you know, for their models that they run, would they have the same issue? Probably. You know, even taking out the data part isn't running the. I've tried it before. I've gone in neuroscience code and tried to reproduce it. No, it's like failed, absolutely. But that's only science. Well, I don't know. Yeah.
People did have anything to do with how times young people educated fully. Because I know for computer scientists, a lot of people, they have a pretty rigorous pipeline. Like, for example, they use on the different algorithms to change their workflow so that
But they can't. So a couple of references to the paper, their rates are just as high. So you would think that because they're trained in this. But there's been a couple of papers in computer science in terms of artificial intelligence, machine learning models, their rates are just as high. Well, I don't know, so I don't think it's having trained in producer rates from the studies that I've looked at.
I think it ties back to reward,
Incentivize.
incentivize,
Yeah.
and disincentivizing, not
Correct. Yeah. Penalize. Yeah.
Kind of going off of that, is there any kind of disincentives for, you know, authors who are submitting their study and then, you know, when it tries to get reproduced, it finds that either they don't, the people reproducing it don't get the same results. Maybe they submitted it to Annals or JASA and then they'd be like, okay, you're blacklisted, must be like months or something like that. Is there any?
I've never, Roland, speak this, so I've never seen that happen where papers happen, labeled non-reproducible. I've never seen that. I mean, if you go to Galvin's blog, and I do must you know, I mean, he talks about this quite a lot. And, you know, what about that is very easy comment as well. But I've never seen The number of retractions in terms of replicability is large, but in terms of computational reproducibility, in statistics, I think never. But that's, I mean, maybe, I don't consider myself a real expert. Yeah, in reproducibility, you know, I'm just in this field. Yeah.
Yeah, like I think code is need to like be public, but for some data, I think there's some privacy laws.
Oh, of course, yeah,
Yeah, like, so is it possible that for every published paper, you have to emphasize some, at least some data with like published data, like, because I know for some data, it's really hard to be public.
Correct. So, you know, we've thought about different ways around it. So, in one of my papers is included here, I didn't include all of the data, but I included certain subjects that they can reproduce the results of certain subjects. Because we're setting the bar very low, we concluded that it's reproducible for those subjects. There's also ways that you can add noise to the data, you know, you might get exactly the same results, but you'll get the same direction or the same conclusion. You know, there are meaningful ways to do this. And accessing, you know, databases in some way that you can reproduce it, or you can go to the database, you can contact the database and reproduce it, but you can't download it to your local drive. You know, there's various ways around this. That like, you know, data privacy is a big, you know, sort of thing in statistics at the moment. How do you get around this from? So I think there's possibilities. I don't have all the solutions to that.
This is just related to that solve privacy of such.
Yeah.
Yeah, from the paper, we over the time we
Yeah. Yeah.
more one. When you look at the impact factor of the higher impact factor generally mean from what you agree better.
I would say in one word, no, but I'll refer you to the paper to see all the details of yeah. If you, as I said, if you try and look at the requirement for data code and then look at the individual journals, it's an interesting, you know, misaligned, not alignment, misaligned. Yeah. Yeah.
When you're going through the reproducibility study with like your 93 MRI papers and you're giving like COVID data to students, did you tell them ahead of time, oh, this is from JASA, or did you not tell them?
No.
So you kept it like anonymous and just said, here's code,
Yeah.
here's data,
Yeah.
what it should.
We find, you know, they told me how much time each of them spend.
So you try to keep it as intelligent as possible.
Exactly. It's hard. Yeah, they can just search it up.
Yeah.
Themselves, but it is hard to try to do. I mean, all of these are pretty good. You know, there is a rank there, but their prominence is this picture. Yeah.
I have one question. I mean, your contribution here is that you pay for your time and effort to reproduce all these results. How long does it take
To do
all the checking codes and reproducibility?
like per paper or in total?
For project, for example, you have a finance, fancy economics examples, you have fMRI examples. How long did it usually take? Like say, how many weeks, how many hours per week?
Maybe per paper.
Per paper, maybe.
Yeah, 93 papers, how long did that take?
Yeah.
fMRI.
Again, what we did was in the first round, we looked at how many papers have no code and no data. They're obviously, they're right.
Yeah.
Then there's the papers that are reproducibly real easy. The only ones that we had to consider was so I was in charge of aligning the group, and I wanted to know where was their disagreement. Right. And when there was disagreement, then we would sit down and discuss it and try and work through it ourselves. So but those papers, the number of those papers was very small.
What would it be? 2 hours, 10, 15?
So some papers we spent days on.
Yeah.
Yeah. Some papers we spent because we wanted to do it as good a job as possible. Right. Yeah. And then some papers not like I said, to be. Not saying that how easy things have worked out with a precedent, somebody said a precedent button. I think Sean here said it, you know, in terms of reproducibility, that's what he defined reproducibility. It was the ones in between. And it wasn't like in the 93 papers, there wasn't man for that spot. Exactly. And then or with a little bit of help, you know, it's all.
Okay, I can ask Ivor again, to call us. And feel free to see this room, give the additional things to discuss with Ivor about all these interesting reproducibility of objects.